Alright, so let's find the eigenvectors of the example 2. Okay, so now here I already found the eigenvalues, but if you fail to find them, okay, you should do it by them yourself. Please refer the previous video. Okay, so let's use the non-repeated eigenvalue first. So lambda 1 is equal to 2. For that, we want to solve the equation a minus 2y times k is equal to 0. So a minus 2y here is a is this. A minus 2y will be negative 2, 1, 1, 0, negative 2, 1, 1, 1, negative 2. Now really here you should pause and try to do it by yourself, because you already know how to find the eigenvectors, right? So try to do it by yourself. This is a non-repeated one. Okay, so and compare it. That is how you learn and develop your skills. Okay, so now you want to solve this equation. What we do is we use Gaussian elimination. So the augmented matrix is negative 2, 1, 1, 0, 0, negative 2, 1, 0, 1, 1, negative 2, 0. Okay, so what can I do here? So first pivot position is negative 2 here. It's non-zero, good. But here I can see I have 1 here. So I will switch R1 and R3. So that I get that nice pivot position that we can imagine, which is 1. So 1, 1, negative 2, 0, 0, negative 2, 1, 0, negative 2, 1, 1, 0. So I have to be very careful, especially when I'm doing a video. Okay, now what can I do here? So here we want to make this negative 2 0. So what can I do? Multiply R1 by 2 and add it to R3, right? So I will write it here. Okay, so 1, 1, negative 2, 0. Here 0, negative 2, 1, 0. So here it will be 0. So 2 plus 1 is 3. Negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. 0. Okay, so we get this. Alright, so now what we want to do is, I think I have made a mistake. This should be 1. Because here it's 1, and why I have 0 here? So this should be 1. Okay, this should be 1. Okay, that doesn't change anything. But that was a mistake. Sorry, that's a copying error. It doesn't change anything. Okay. Now we want to make, we want to make this 1, 0, right? So what can I do? Well, I can subtract the first row from the second row, right? 1, 1, negative 2, 0. Here 0. Negative 2 minus 1 is negative 3. Negative 1 minus 2 is 3. 0, 0, 3, negative 3, 0. Okay, good. Now let's go to the second pivot position. Okay, because we have 0s here. We completed that task. Negative 3. I would like it to be 1 for the perfection, but it's okay. Okay, because here if you directly, when you add it to the third row, this part becomes 0. So let's add second row and third row, because negative 3 plus 3 is 0. So here what we get is 1, 1, negative 2, 0. 0, negative 3, 3, 0, 0, 0, 3 plus negative 3, here also 0, so ideal scenario plays out. So this is our final result. So we stop here. But well, we can do one thing. We can divide the second row by 3. Okay, so we get negative 1 and 1 here. So okay, I divided the second row by 3. Okay, now furthermore, really you can and do the Gaussian elimination and create zeros here and here, but you don't have to. Okay, you can stop here. Just try to keep it simple. We are not doing the complete Gaussian elimination. Okay, so now let's rewrite the equation out of here. So 1, 1, negative 2, 0, negative 1, 1, 0, 0, 0. Okay, K1, K2, K3. Okay, all right. So now let's write the equation. So K1 plus K2 minus 2K3 is equal to 0. Negative K2 plus K3 is equal to 0. Okay, so from here, from the relationship, so we can use the second relationship first. So K2 is equal to K3. Okay, so tell me a smart choice for K3. K3 we can choose 1, right? So we can choose 1 for K3. What is then K2? K2 is also becoming 1. So now let's find K1. K1 plus K2 is 1 minus K3 is negative 2 is equal to 0. So K1 minus 1 is equal to 0. 1 minus 2 is negative 1. So K1 is also 1. So our eigenvector corresponding to the eigenvalue 2, which is an unrepeated eigenvalue. So for the eigenvalue 2, the eigenvector is 1, 1, 1. Okay, all right. So now then we have to find the eigenvectors for the repeated eigenvalue. So this is the special case. So let's begin it in a new node. Okay, here. All right. So the eigenvalue, the repeated eigenvalue we know is negative 1, and the matrix A is, let me write down the matrix A, 0, 1, 1, 1, 0, 1, 1, 1, 0. Okay, so we want to find the eigenvector here. So let's see what case plays out. Okay, all right. Now we want to find the A minus lambda I matrix. So here A minus I, right? So that means A plus I, right? So we want to add identity to this matrix. So A plus I matrix is here 1. You add 1 to the diagonal, 1, 1, 1, 1, 1, 1, right? So that is what you get. Okay, so it seems to be like very nice. Now we want to find the eigenvector. So what you do is 1, 1, 1, 1, 1, 1, 1, 1, 1 times little k1, little k2, little k3 is equal to 0, 0, 0. So now you want to solve this equation. Okay, so now we can use the Gaussian elimination. Really, we don't need the Gaussian elimination if you carefully look at this, but I will still do it. 1, 1, 1, 0. Here 1, 1, 1, 0. Here you will immediately see 1, 1, 1, 0. Now the pivot position is 1 here. It's the ideal because it's 1. Now you want to create zeros here. What would you do? You subtract first row from the second row. 1 minus 1 is 0, and you subtract first row from the third row also. So I do it fast, okay, because you can get 0, 0 here. So 1, 1, 1, 0. So 1 minus 1, 0, 1 minus 1, 0, 1 minus 1, 0, 0, 1 minus 1, 0, 1 minus 1, 0, 1 minus 1, 0, 0. So you, with a one step of Gaussian elimination, we get everything, okay. So we get the equations 1, 1, 1, 0, 0, 0, 0, 0, 0, K1, K2, K3 is equal to 0, 0, 0. Really, if you look carefully here, do you see we only have a one equation, K1 plus K2 plus K3 is equal to 0. So even we didn't need to do the Gaussian elimination, but now it's very visible from here, because this will not produce equation, this will not produce equation, right? So only equation is K1 plus K2 plus K3 is equal to 0. Now here is the scenario. Here's the most important step. Now this we are dealing with case 1, which is our eigenvalue, repeated eigenvalue is -1, and now carefully look, we get 2 eigenvectors. That means algebraic multiplicity is equal to geometric multiplicity. Take a closer look. We don't only get 1 eigenvectors, we get 2 eigenvectors. Look at how I do it, okay? Learn it. K1 is actually negative K2 minus K3. Now here's the difference. Can you assume a value for K2, K3 for example? Pick a choice. Make a choice for K3 and can you get K2? No, right? Choice for K3 doesn't give you K2, or choice for K2 doesn't give you K3 and K1. Okay, because you only have a one equation. Remember, let's compare. Let's go back. Here, look at when we have non-repeated eigenvalue. Here we make a choice for K3. We get K2, then we get K1. We only need to choose K3. We assume K3 1, then we get K2 automatically and K1. Because we had two relations. Here we only have a one relation to work with. So just choose K3 1. Then what is K2? What is K1? You don't get that. So let me write down what I do. So really, we cannot choose K3. We cannot choose K2. We have to choose K2. K1 is actually the only relation is minus K2 minus K3. So this is how I write my eigenvector initially. Carefully look at this how I wrote. Okay. K1 is negative K2 minus K3, but we know nothing about K2 and K3. Now this can be decomposed as, let's choose K2s. Okay, let's write the K2. See here, the way I can write it is, here we have a K2 negative 1, coefficient of K2. Here the coefficient of K2 is 1 on the second term. On the third term, there's no K2, that's 0. So this is the coefficient of K2. I can write the same vector as a decomposition. Here the coefficient of K3 is negative 1. Here the no K3. Here K3 is 1. Okay. Alright. So now you can say, now we have two eigenvectors. Okay. Here's how you can do it. If this is too complicated for you, here's how would I do it. When you come up with a case where you can choose K3 as some kind of a number and it does not give K1 and K2 immediately, where you have this complicated relation, what you do is you can make two choices, because really you have to make two choices to get K1, right? You have to make two choices, not just a one choice. So make a one choice. One choice will be choose K2 to be 0. If K2 is 0, what do we get? K1 is negative K3. Okay. Now you can choose K3 to be 1. So then K1 is negative 1. So this is a one eigenvector. By choosing K2 is 0, then K3 is 1. Okay. Now the other choice you can make is K3 is 0, K2 is 1. Okay. So K3 is 0, K2 is 1. So then K1 will be negative 1. So this is how you get the two eigenvectors. Okay. You make two choices. You have to make two choices, but you make two choices like 0, 1. That's a one choice, and 1, 0, that is the other choice. Or if this makes sense, try to write the relationship in a vector sense, okay, in this vector, okay, and then try to decompose it. So I will do 3 examples from this type of questions. So carefully look at these 3 examples and learn how would you find the eigenvectors. So let's do a summary. Okay, let's write down everything. So for lambda is equal 1 is equal to 2, the non-repeated eigenvalue, the eigenvector is 1, 1, 1. Then we had the eigenvector negative 1. Okay, it's repeated. So the two eigenvectors we got negative 1, 1, 0, and then the other eigenvector is negative 1, 0, 1. Okay, so this is how you can get two eigenvectors. The reason we were able to get two eigenvectors because we had to make two choices here. We had to choose our K3, we had to choose our K2 both. But versus in previous cases, we only choose K3, then we get K2 and K1 for free. Okay, so try to see the difference, and please watch the other examples and learn. Okay, all right. So how to write the solution, we will learn it in a future video. Okay, all right. Thank you.